Okay, let's talk about trucks. So there are 48,000 miles of interstate highways in the United States, which means that having a good road network means that you can drive basically to any destination in the United States. This large expense on infrastructure helps companies, businesses, people keep their transportation costs low, because poor roads means more maintenance, maybe more fuel usage, but good roads going across, crisscrossing across the continent mean that you can drive, you can find a short route to different places. Which is why truck is a popular mode of transportation. A lot of companies will use trucking for hire. They'll hire services of a trucking company, a carrier, to move their goods. Some companies will have private fleets as well. Why do companies have private fleets? That's an interesting question. Sometimes it is to make sure a sufficient amount of capacity is in-house, so they're never worried about being short of capacity, especially in certain time periods of the year where a lot of movement of goods might be taking place, such as before a holiday season where retailers builds up inventory. Another reason could be that companies feel they could reduce their transportation costs by having their own fleet. There are 787,000 active carriers registered with the Federal Motor Carrier Safety Administration. That's a lot of carriers. And these carriers collectively have about 3 to 4 million heavy-duty trucks, which means that the average carrier has about 5 trucks. It's a really small operation. Okay? A lot of carriers are just one person, they've leased a truck, and now they're a carrier company picking up loads from different customers and moving the loads around. A lot of companies will have just 2 trucks or 1 truck, and the bigger companies with like many trucks are fewer. The American Trucking Association says if you have it, it moved by truck, and by now you understand why. Because even if you use rail or air, the connectors at the end, the drayage going from terminals, airports to the destination address, or from the source address to the terminal or airport, is going to be trucks. Okay? So it's a very popular mode of transportation. It's pretty reliable. It is more expensive than rail by a lot, but it is cheaper by air by a lot. And it sits in that nice middle where it gives you reasonable speed, because a lot of these trucks, they average 500 to 600 miles a day. So you can go from New York to LA, maybe like 4 days, 5 days, or less, as we'll see, if you have multiple drivers in the truck. So the truck doesn't need to stop at night. One driver rests while the other driver drives. So trucks are often used for finished and semi-finished manufacturing goods because these goods are more value dense. So we can afford to pay trucks for their shipping. Cheaper raw materials like lumber, it tends to be too expensive to ship them by truck often. So often rail is used to do the long haul. Trucks use freight in smaller sizes compared to rail. So a lot of shipments on truck are less than 10,000 pounds, which is LTL size, less than a truckload. They're characterized by low fixed cost and high variable cost, like operating a truck, because the fixed cost is just the lease of the truck, but then the variable cost will be fuel, maintenance, salary for the driver, and things like that. The very high accessibility, door-to-door service, faster than rail or barge, slower than air, more expensive than rail or barge, less expensive than air. High cost compared to rail and barge, but low cost compared to air. Reliability is good, but can be affected by weather. And many carriers, it's a very competitive industry, especially the truckload industry. As we'll see later, truckload and less than truckload are kind of almost like different modes of transportation. They're quite different. And so in the truckload industry, where the truck picks up a load, that fills the truck, or they're being paid for the whole truck, and they just go from point A to point B. They don't have to go to any terminals or offload or reload or pick up multiple loads. Just go from point A to point B. That simple service, you have a lot of carriers because anybody can lease a truck and register themselves as a company and start picking up loads. So you have many, many small companies picking up loads. Let's look at the industry fragmentation. As we'll see in rail and LTL trucking, for example, there are a few large players. But in truckload trucking, you have a lot of trucks which are just 1 to 2 fleet size. Okay? The sources for the data I'm using are given in the notes for the slide. So if you want to check where the data came from, you can check the notes for the slide. All of the data is data reported by government agencies and collected at websites like Bureau of Transportation Statistics and stuff and places like that. So if you look at it, most trucking companies or carriers are just 1 to 10 fleet size, 1 to 10 trucks. And then very few go above 10 trucks, and more than 100 trucks are very, very few. The typical trucking company is just an owner operator with a truck or 2 trucks. So why do we see such industry fragmentation? Because there are low barriers to entry. So anybody, like, you could go out, if you have a truck driving license, you can go lease a truck and obtain an MC number for relatively low capital outlay. And so the market is almost perfectly competitive, where there's lots of competition. It keeps margins low. Now, sometimes when COVID happened, for example, there was demand for trucking more than capacity and the rates went up. But in normal circumstances, the trucking rates are very competitive, and the margins on operating a truck are not very high. I mean, people make some money, but it's not very high margin. Because if there was a very high margin, we're making lots of money, more people would join the industry because their barriers to entry are low and compete away the high margins. There are some economies of scale challenges. So small carriers can't afford sophisticated routing software or fuel hedging contracts. Fuel hedging contracts are a way to take care of risk of fuel prices going up. So you can buy a forward contract where you say, okay, 3 months down the line, you are allowed to buy fuel at a particular lock-in price. You can lock in some future prices by paying some premium, a small amount of premium. And that way you are hedged against increase in fuel price. So these future contracts, you can learn more about them in finance, but they're very important to hedge risk, especially of commodities, raw materials, fuel, things like that. And then maintenance facilities that the big players have. So a lot of these small companies are just a truck, Google Maps, and maybe some software to look at where people advertise loads and pick up loads, and that's about it. What this means is if you're a large company and you have lots of shipments going all over the place, you may be dealing with hundreds of carriers. One carrier has 3 trucks, one carrier has 5 trucks, one carrier has 1 truck, and you're sometimes dealing with this carrier, sometimes dealing with this carrier, dealing with so many people. And that's a lot of administrative overhead to deal with so many small players, which is why in the industry we have these middle players, third-party logistics provider or freight brokerage companies, where you will go as a large customer to them and say, okay, these are my shipping needs, and they will organize the shipments for you by dealing with many different trucks. And because that's all they do, they get very good at it. They know which companies are more trustworthy, reliable, and they've been dealing with them for a long time. And so they can really help out companies in dealing with many, many small carriers for truckload shipping. Okay. So your freight brokerage company or 3PL, you don't have to worry about finding capacity and finding many different small carriers to give you the shipment, the trucking capacity you need. Just go to them with your needs, and then they do the rest of the work for you. Now, how much can you ship on a truck? Okay. So obviously, whenever we talk about transportation, there are 2 things to watch out for. There is a weight limit. Okay, most things have a weight limit. Containers, for example, if you go above the weight limit, it can change the shape of the container, damage the container, so you have to be within the weight limit. Trucks get their weight limit from highways, because you can't drive something too heavy on a highway, it will damage it. And so the total truck trailer combined limit is 80,000 pounds. Now, when we say truck trailer, truck is this front part of the truck with the engine. And then the back box looks like a rectangular box where you load up your stuff is called a trailer. Okay. So the truck trailer combination, the whole thing, okay, this whole thing can weigh up to 80,000 pounds. Now, the truck and the empty trailer typically weigh 36,000 pounds, which means what is left over is 40 to 44 or 40 to 45,000 pounds. Okay. Some states may allow for higher or lower weight limits, but this is like the federal guidelines. So you can ship, 40. A lot of times companies will try to be a little bit under 45 just to make sure they don't hit 80. So they'll ship like 42, 43,000 pounds in the trailer for a truck. Now, depending on how dense your goods are, 43, 44,000 pounds may not use up all of the space in the trailer. Or sometimes what we call it, what we call getting cubed out. So you use up all the space in the trailer. You're still not at 42 or 43,000 pounds. You're much less. But your good is very fluffy or less dense. It takes up a lot of space. Imagine shipping ping pong balls. You'll fill up the whole truck trailer well before you get even close to the weight limit. Like you fill up the whole truck trailer, it might only be like 15, 20,000 pounds or something or less, right? But there's no more space to put in more ping pong balls. So that's called getting cubed out. You have no more cubes of volume to put stuff in. If you're putting something extremely heavy into the truck, you may get weighed out. You may hit 44,000 pounds, but there's still half the truck is empty, but you can't put anything else in because you're weighed out. You're at the weight limit. Okay, so you have to look at both the weight limit and the volume limit. This is the weight limit for how much you can ship in a truckload. Now, trucks are used to connect terminals of other things like train terminals, air terminals or airports by all logistics systems, and so they account for the majority of U.S. freight expenditure. Because even if you are deliveries within a city, distribution within cities or within local regions, and then connecting terminals for other modes, and then also doing the full truckload and LTL shipping, they're used all over the place. They're very, very useful. Transit time that the trucks, how long it's going to take the truck, is influenced by hour of service rules and speed limits. Hour of service rules specify how long can a driver drive before they must take a break. Okay, so I'm going to give you a cheat sheet with the important rules summarized, but the summary of the summary are the rules on this slide. Okay, when drivers start working, even if it's not driving, even if it's just checking documents, doing an inspection of their truck to see it's safe to drive, leaving their terminal to go to a customer location, all of that time is work, and so the work clock starts. Okay, and they have to stop working after 14 hours to take a 10-hour break. So think about 24-hour day. There's a 24-hour day. It's broken into two chunks for truck drivers. You can work for 14 hours and you must rest for 10 hours. Okay, so that's their day, 24 hours. 14 hours of work, 10 hours of rest. But the 14 hours of work is again subdivided because all of this 14 hours cannot be driving. Out of these 14 hours, only 11 hours can be driving. So you can think of it like this. At most, a tractor will drive for 11 hours. On top of that, they can do 3 hours of other work. For example, they must take a break after 8 hours, a 30-minute break if they've been driving for 8 hours consecutively. And so the 30-minute break will count towards those 14 hours of work because that's like you're still on the work, but it will not count towards 11 hours of driving. Plus, you may have documentation or inspection to do or loading or offloading of the truck. You're present there. So all of that time counts towards the 14 hours, but not the 11 hours of driving. Okay. So 11 hours of driving time, additional work you can do up to 3 hours, 14 hours of work. then you must do 10 hours of rest. Within the 11 hours of driving, you must take, it takes more than 11 hours to finish 11 hours of driving, because every 8 hours you need a 30-minute break, which counts towards the 14-hour work rule, but not the 11 hours of driving. So if you drive 8 hours, take a 30-minute break, you can still drive 3 more hours. So in 11 and a half hours, you would have driven for like 11 hours. Okay. The more hours you can obviously drive, the further you can go in a day. And so one way to have the truck moving all the time, just stop for like gas or something, is to have 2 drivers in the truck. Because at the back of the seats of the truck, there's a sleeping berth. So driver 1 is driving, driver 2 is sleeping at the back, and then they swap. And so because each driver can drive for 11 hours, both drivers combined can drive for 22 hours of the day, and the truck only stops for 2 hours in a whole day. So that way the truck can go a lot farther, and that really speeds up, you can cover a lot of distance between 2 hours of driving. And that really reduces transit time of trucks and speeds up your delivery. However, it's obviously more expensive because you have to pay for 2 drivers, not just 1 driver. It's usually not double the cost, but it's more expensive than having a truck with 1 driver. So trucks with a solo driver can usually average 500 to 550 miles per day. You might say, well, speed limit, for trucks is like 60 miles per hour. If you drive for 11 hours, they should be doing 60 miles in a day. Well, you're not always driving at 60 miles per hour. You have to take an exit to fuel. You may run into some traffic. Part of your journey might be going through cities, toll booths, weighing stations, or just traffic jams, and things like that. So you're not able to average 60 miles per hour for 11 hours continuously. Sometimes you're at 60 miles per hour, sometimes you're at 40 miles per hour, sometimes you're at 30 miles per hour, sometimes you're fueling, right? So the whole total combined, trucks will average 50 to 50 miles per hour over 11 hours, which means they cover about 550 to 600, maybe up to 600, but usually 500 to 550 miles in a day. With a tag team, you double that. So they can go up to 1,100 miles or a little bit more, because 1 driver sleeps, 1 drives. So total, each driver can drive 11 hours. So you drive for, about 22 hours in a day. Shippers will pay a team premium, often 20 to 30% higher rates, because a team can move freight from New York to Los Angeles in 2.5 days, whereas the solo driver would take like 5 days, right? So you get double the speed, because you cover twice as much distance in a day with a team driver, so you pay a premium for that faster shipping. With the team premium, trucks are still going to be much cheaper than air, okay? But they're starting to get in the range, because imagine shipping something by air New York to LA with the dryest time and the time before the flight leaves, and then arriving at LA, and then the time it takes to get your luggage cargo out of the airport and then down to the destination on a truck. That whole thing might take 11, 12 hours, or depending on the flight schedule. Flight may not be scheduled exactly when you want it, so you might have to wait for the flight. Even if there's a flight going every day, like 1 flight or 2 flights, you may have to wait on average 5-6 hours for a flight. So when you add that waiting time for a flight and then the time to make the actual trip, with the times at both airports, you're looking at close to a day. So if air is going to take you, between half a day to 2/3 of a day, or close to a day, and the truck's taking you 2.5 days, you're getting in the ballpark of air. Not exactly, you're still like 2.5 times more or 3 times more in terms of time, but you're also like 5 times cheaper or something, and so it could be pretty good. Now that's a very long shipment. For much smaller shipments, trucks can give you a big radius of area where they can do same day delivery, because they can go, with the 2 drivers, they can go up to 1,000 miles in a day. So that's a pretty big area where you can do deliveries same day within 24 hours. Okay, so this is a cheat sheet for the hours of service rules. Now the thing that the cheat sheet is adding to what I told you before is the weekly limit rule. For example, you cannot drive after being on duty for 70 hours in any 8-day rolling period. So within over 8-day period, you can work, or you can drive for at most 70 hours. And you can completely reset your 70-hour weekly clock by taking 34 consecutive hours off duty, like a weekend. 34 hours is 1.5 days about. So if you take 1.5 days off, then you can reset your weekly limit. So there's a weekly limit, and then there's also a 7-3 or 8-2 sleeper berth split rule, which means that instead of driving for 11 hours and working some hours to get 14, and then taking one 10-hour break, you can split your 10-hour break, okay, into a larger break and a smaller break. The smaller break can be 2 hours. You can't split it into like an hour break, then another hour break, then another hour break. You can have hourly breaks. At most, the smallest you can get is a 2-hour break, and then you have to take the 8 hours in one go. So it can be 8-2, or you could do 7-3. Okay, maybe you can do 6-4 as well, but like the lowest is 2 hours. Okay, and then the 2 breaks, the larger and the smaller, must add up to 10 hours. So what's the benefit of this split? I'm going to show you with an example. A solo driver, Maria, is hauling a load of automotive components. Her truck is equipped with electronic logging device, ELD. Why is this part important? Why is this part in the question or the example? Because ELD lets you easily manage your time. On the ELD device, you can click, okay, taking a break, take a 2-hour break, click, okay, starting now. It'll keep track of the time. You don't have to write down time and keep a watch and look at the time and do all that. The ELD device will tell you, okay, you've driven for 11 hours now. Okay, you've had this much break, then you need this much break, things like that. So that'll help you with tracking your hours. So 6 a.m. Maria starts work. She's a pre-trip inspection. So as soon as she starts work at 6 a.m., her clock starts. The 14-hour clock starts. Okay, and so 6 a.m. plus 14 hours gives you 8 p.m. So Maria has to stop working no matter what at 8 p.m. unless she takes the split break, because when you take the 3 hours or the 2 hour in the split break, your 14-hour clock stops. Otherwise, it never stops. Okay, so she drives. She did a 30-minute pre-trip inspection. At 6:30, she starts driving to the source place, which is going to pick up the load, and she drives 2 hours to get there. That time is going to count for driving time, by the way. So going to the customer's warehouse to pick up goods, that counts as driving. So at 8:30, she's at the customer's place, okay, at a supplier for a pickup, but the warehouse is disorganized. They're not ready for her. So you tell her, park and wait. We'll be ready. Park your truck with the dock. We'll have your truck loaded, ready to go in 3 hours, because we're still looking for stuff in the warehouse. We're doing X, Y, Z, whatever, right? Now she has 2 options. She can just wait for 3 hours and her clock will keep ticking, or she can take a 3-hour break with a 7-3 split, take the shorter 3-hour break, and then her 14-hour clock will stop. Okay, so 11:30 Maria departs with the cargo. So what happens if she takes the 7-3 split and counts the 3 hours from 8:30 to 11:30 when the warehouse is working on her, loading the truck and doing other things? If she counts it as break, what happens? And if she doesn't count it as break, she's just waiting and it's not using that as a break, what happens? Let's look at both cases. We're going to assume average speed of travel is 50 miles per hour for this region where she's working, or for Maria, right? And so we know that if she's able to drive the full 11 hours, she'll be able to do 550 miles in the whole day. That's her range, if she's able to drive the whole 11 hours. But this warehouse stuff could mess her up. So let's see what happens. Let's look at the no split standard rules, okay? So Maria does not use the 7-3 split. The 3 hours she spent waiting will count against her 14-hour rule. So when she starts at 11:30, leaving the warehouse, starting her actual journey with the cargo, she's already been working till 6 a.m. She's already worked 5.5 hours. Although she's only driven 2 of those hours, she's been working for 5.5 hours. So you have to subtract the 5.5 hours from 14, because you can only work 14 hours in a day. You've got 18.5 hours left. Okay, she only drove for 2 hours by 11:30 a.m., so she has 9 hours of driving left, but she cannot work more than 8.5 hours. On top of that, the 8.5 hours left, she can't even drive those 8.5 hours, because after she drives 8 hours, she must take a 30-minute break. She has to stop at 8 p.m. regardless of where she is, okay, because of the 14-hour rules. She started working at 6 a.m. to 8 p.m. and she must take a break of 30 minutes at 7:30 p.m. after 8 hours of driving. Okay, so really from 11:30 to 7:30, that's the time she can actually just drive. Okay, and that is 8 hours. So at 50 miles per hour, driving for 8 hours, she covers 400 miles, and then that's it. She'll take a 30-minute break, and then when the 30-minute break is over, she has to call it a night. She's been working for 14 hours. Done, dusted, only able to move cargo 400 miles in a day. Now, let's imagine she does a 7-3 split. So while the warehouse is loading 8:30 to 11:30, she uses 3 hours of her break. Okay, so at 11:30, she's only been working 2.5 hours. Driving 2 hours, working 2.5 hours. So she still has, a lot of hours left because she only worked 2.5 hours out of 14. She has 11.5 hours left. Okay. So she can work till 11 p.m. now. She doesn't have to call it at 8 p.m. Okay. So you're going to drive 8 hours first till 7:30 p.m., take a 30-minute break, and drive another hour from 8 to 9 p.m. to get to her 11 hours of driving. Okay. And then she can do other work till 11 p.m. if she wants to, like paperwork, inspection, whatever. But she has to stop driving at 9 p.m. She's driven 11 hours now. So because she's able to get her 9 hours of driving with the cargo, 2 hours without the cargo in the morning, she's able to cover for 50 miles. So her range went up by 50 miles, or an increase of 12.5%. So imagine if all of your trucks, whenever they had this warehouse delays, they were able to use their brake smartly to get a 12% boost in their range. That would add up in savings over the year, because you'll be able to, travel more in a day, finish things earlier than you would otherwise. Now, before we move on and talk about LTL, we want to understand this terminology. A line haul is a movement of cargo between 2 points. A long haul, line haul, another word for that is long haul. If you're going more than 250 miles, you call it a long haul. If you're going less than 250 miles, you call it a short haul. This is no set rule in stone. Some people call it more than 400 miles a long haul. But basically, if you're going 250 miles, the idea is you can go 250 miles, drop the cargo, and come back in the same day. So you can return to your base terminal or your home station, your home. You go up in the morning, pick up the cargo close to home, go to 50 miles, come back to 50 miles, you're home to sleep, spend the night with your family. So that's why that's short haul. You can return home in the same day, up to 250 miles. Because above 250 miles, you may not get back home because you usually can't do more than 500 miles in a day. Okay, so that's why it's called a short haul. You can return home or return to your terminal where you work. Okay, but above 250 miles, you can't return home same day, so it's called a long haul. So that's short haul versus long haul, but both are like line hauls because you go point A to point B direct. You don't have terminals and other detours in middle. Okay. The other thing that is some trucks will do, especially in LTL, is what's called a milk run, also called round robin. Milk run is a trip that starts and ends at the same point, whereas a line haul, which is short haul, long haul, they start at point A and end at point B. Even if you're coming back home the same day, that's your return trip. That's not like a trip with cargo. So the trip with cargo is just point A to point B. Whereas in a milk run, you go around, you can do a collection trip. You go around, you hit 4 or 5 customers, collect small amounts of cargo from each to fill up your truck and come back to your terminal. Or that's a pickup type of trip, collection trip. You could do another trip called a distribution trip, where you pick up a lot of cargo from your terminal and you go drop it off at multiple customer locations, 4 or 5 customers, their factories, warehouses, whatever, and you come back to your terminal. So you do a collection milk run or a distribution milk run, and LTL shipments do that because they have multiple shipments in a truck. So the phrase milk run originates in American culture, where distribution of milk by bottles by the milkmen was done. The milkmen have a daily route. They would drop off bottles filled with milk, pick up yesterday's bottles which were empty, and do that run, distributing and collecting at the same time, and then do it again the next day. So let's look at the difference between LTL and TL. I mentioned how LTL and TL are very different. Okay, so LTL specializes in smaller loads, typically 150 pounds to 10,000 pounds. Above 10,000 pounds, or a few thousand pounds more than that, maybe 12,000, 13,000, 15,000, somewhere in that range, it is equal cost to do a full truckload versus LTL, so you'll just do a full truckload. If you can afford, if the full truckload costs the same or less, you'll always go full truckload because it's going to go faster. It's not going to go through all the LTL terminals. It's going to point A to point B direct. So you always prefer TL if you can, right? So TL will ship 15,000 to 45,000 pounds. LTL is usually shipments less than 15,000 or less than 10,000 pounds, because at less than 10,000 pounds or 50,000 pounds, LTL is going to give you a lower cost total for the shipment versus sending out mostly empty truck in a truckload shipment. LTL though is not point to point direct. It's not direct. They employ facilities for collecting and storing freight and housing drivers and equipment. So a truck will do a collection run, pick up stuff from all the customers in the city, bring it to a terminal where this cargo will get sorted. Often they need your stuff to be pelletized because they can move pellets with forklifts. So in their terminal, they'll move pellets with forklifts, and then they'll make trucks to go to different destinations. So all the shipments going west, they'll be put on one truck. Okay, you go west. All the shipments going south to Florida, Texas, you get put on one truck. Okay, you go south. All the shipment going, southwest California, you get put on one truck. Okay, you go there. So they collect shipments from a region, bring them to a terminal, then they offload that goods from all the collection trucks, then they combine those shipments so that shipments going to the similar cities or the same cities or two nearby cities will go on the same truck. Then they send those trucks out. When they arrive at the destination cities or near the destination cities, they'll go to their company's terminals, and there they will be offloaded, and then delivery trucks will be loaded. Delivery trucks may have different requirements. Some need a ramp because the delivery is not to a warehouse with a dock. So you need a ramp to offload the stuff. Some delivery trucks may be smaller to go to downtown or cities or in residential areas. Some delivery trucks might be just huge big trucks like the normal 53-foot trailer truck combo, and they might be delivering in a particular route, and then some other truck will be doing another route. Okay, so at least you're going to hit two in an LTL shipment. You have a milk run to pick up the goods at the source. Then you make your long haul trucks. By mixing, matching the goods that you collected from different customers, different destinations. Then you do a line haul to a terminal at the other end of the journey, where again the truck which does the line haul, they'll offload the stuff and load up into delivery trucks, and then you'll milk run to do your deliveries. Sometimes you even stop at a terminal in midway because you may have a shipment, a truck which is shipment for Texas and Florida on it, and it may go to some terminal where it gets split into two trucks and then or gets offloaded, and then they make a full truck from there to Texas and then a full truck from there to Florida, and then the journey splits at that point. And then you get to a terminal in Texas and you get a terminal in Florida, right? So you could have the LTL journey could be going through 3 LTL terminals, not just 2, but at least you go through 2 LTL terminals. So at the very minimum, you're going to do a collection milk run to terminal, then the long haul to the other terminal, and then a distribution milk run, where the TL just goes door to door straight, doesn't go to any terminals. Okay? LTL carriers require investment in terminals, sorting facilities, equipment to move pallets in those terminals. So there's a greater concentration in the LTL carrier market because the cost of entry into the business is so high. You have to set up these terminals, equipment, hire workers, and do all this stuff. So let's look at the LTL shipment process. So you do a collection milk run, collect loads from multiple shippers. You could have delivery collection at the same time. So if you're delivering to a customer, collecting from the same customer, you might combine that into one milk run. Then you sort loads in terminals, combine loads by destination, and load onto line haul trucks. Remember, the collection truck may be smaller than the truck that's going to do a line haul, depending on the quantity of the load it's going to pick up. And sometimes when you're picking up load from a city, you might have smaller trucks may have more access. After you combine the loads into destination onto line haul trucks for the big part of the journey at the terminal, then you'll do a line haul. Okay, which will be a full truckload for the LTL company, but within the truckload there'll be multiple customer shipments within it. Okay, so this truckload comprises of multiple shipments from different customers. Then you do the break bulk. You'll split the amount, the goods in this line haul truck, offload them into the terminal, and then you will kind of sort them. Okay, which goods are going to which city or which zip code or which county, and then you do delivery trucks for those. Okay, and then you delivery milk runs to deliver the final shipment. The 1, 2, 3, 4, 5, 6, at least 5 steps, whereas TL shipment is just like pick up, go and drop, like 2 or 3 steps, right? It's just very simple. Just pick up and then go straight to destination and drop. The 2 terminals for the combined step and the break bulk step, you don't have those 2 terminals, and you only collect from one customer. You're not going around collecting from multiple customers usually. Now, some TL shipments, you can if let's say you have 2 facilities, and you have cargo in both of them and you want to combine them into one TL shipment, some truckload companies or drivers for an extra charge will make an additional stop for you and get some more cargo from the additional stop if there's space in the truck. So, but that's still not a milk run, because you're just maybe doing like one extra stop in another facility by the same customer, not going to like 5, 6 different customers and so on. Okay, so this is a picture of a sleeper berth. You can find more pictures online. Long haul truck drivers often spend weeks away from home, sleeping at truck stops or in rest areas, and it's relatively dangerous work because of accidents, possibility of accidents, and you already talked about working in teams of 2 to reduce transit times. But that's just to tell you a little bit about that. The truck driver's life is not an easy life. Okay, let's talk about rail. This is another very important mode of transportation, used a lot for raw materials movement, because raw materials are not value dense. Like a pound of raw material doesn't cost a lot, so you can't spend a lot of money on transporting it. So you can use rails. Also used with truck, rail plus truck combo intermodal transportation is also used when the transportation is not time sensitive. You can afford to spend time on rail, but you want to save the money because rail is much cheaper than truck. So US has a lot of railroads, 140,000 miles, okay, which really allows the US economy to move a lot of goods at low cost. It's the largest railway track network in the world, and it connects to the Canadian railway network, which is 30,700 miles. And so, even if your supplies in Canada or your customers in Canada, you're shipping there, rail can just, take you there too. It's a long hauler. Usually people pick rail for longer journeys. Remember we saw the example of moving something 300 miles or so on, and we said that because of the time spent at the railway terminals and the drayage, moving with the truck to the rail terminal, and then at the other end from the rail terminal to the customer's door, all of these time-consuming activities, they make rail really slow for small shipments, but for very long shipments, the time spent at the terminals and such stuff is constant. So for very long shipments, it can still make sense to use rail because a small portion of the total time is drayage time and terminal time, whereas for a small shipment, majority of the time is going to be spent at the terminals and less time moving. Okay? It's very high fixed cost, set up a railway line, but it owns right of way, so there's no congestion issue. You don't have to wait for traffic. Okay. Almost the entirety of the 140,000 miles of railway track are owned by Union Pacific, BNSF Railway, Norfolk Southern, and CSX Transportation. So like 4 large players own most of the network. A lot of the freight moves in carload quantities, which is like a truckload version of the rail. So carload quantities or full carload FCL, and FCL rates are cheaper. And usually you're moving raw material in like larger batches anyway. But there is a possibility of doing less than carload rates as well. And another thing with rail is that you get these flatbed rail cars where you can put containers on top. So if you're importing stuff that comes into a port as a container, a metal box used for international shipping, the container can be loaded onto a train, and then the train can take it further inland or to some other destination. So then you would be shipping like a container load, right? The train is not going to open a container and mix and match for you, but you'll be shipping a container load on a rail. But other than the container load, you can ship full carloads, or you can also ship less than carloads. Less than carloads is more expensive because then the railway terminal, they have to load your load onto the car, and then if there's empty space, they can load somebody else's load on the same car. Larger freight cars and longer trains are increasingly being used because they are more fuel efficient and cost efficient, to send one really long train from like Detroit to Seattle, something like that, whereas to send multiple small trains is more expensive. Some carriers do offer stop-off privileges if they have rail terminals in other cities and the train is going to pass those other cities. Some of the cargo can be offloaded on those intermediate points along the journey. Now, why is rail still being used so much? It's slower than truck because it has certain advantages. The first one is fuel efficiency, which is why its costs are so much lower. Okay, a freight rail can do 480 to 500 ton miles on a gallon of fuel, like a diesel or whatever. And ton miles means it can move 1 ton that many miles. So it can move 1 ton, 480 to 500 miles on a gallon. Whereas heavy duty trucking can move 1 ton, 134 miles on a gallon. Now, you might say, well, a truck is not going to give me 134 miles on a gallon. Yes, but it's also carrying 20 tons, right? So the truck may give you 6 miles on a gallon, but it's carrying 22 tons. So 22 tons times 6 miles per gallon will give you 134 ton miles per gallon, okay? So the unit says ton. Usually trains and trucks don't move just 1 ton this large distance. They move a lot of tons, a smaller distance, but you multiply the tons by the distance moved. This is the fuel efficiency numbers you get, and you can see that the rail is about 4 times, 3.5 times to 4 times more fuel efficient. CO2 emissions, 75% lower than trucks. Okay, and that can be important. So for example, if your company has a mandate to reduce their carbon dioxide emissions and you use truck shipping and you're able to move some of your truck shipping to railway shipping, that's a big win right there. It reduces road congestion because one train can carry stuff that you need 280 plus trucks to carry. Okay, one truck's carry 20 tons, so you multiply 28 tons by about 300, and you get about 6,000 tons. That's what one train can pull. Okay, so it can reduce get loss of trucks off the road by using more rail, and using trains, right? You can see the cost is different, and I've shown you the cost graph already in the beginning of the lecture over time, and so you can see that 3 to 4x cheaper. This is at one point in time, but over time it's usually been about 4x cheaper than trucks. Mostly used for long haul 500 plus mile journeys because smaller journeys you spend so much time on the terminals that it's not worth it. You might as well just send a truck, and you're not saving a whole lot of money. Well, you are saving money, but it's over if the rate is lower, but you're traveling a small amount, like only 100 miles, you might save a small amount of money total, even though the rate is much lower because you're multiplying the rate by a short distance. So let's say the rate is 0.05 versus 0.15, so you're saving 10 cents per ton mile. But if you're only shipping something 100 miles, 0.1 times 100 is $10. So you save $10, on that. But there's additional cost to do with handling at terminals, and for trucks there's an additional fuel surcharge on top of this. So this is not the whole amount you'll be paying, but on the actual rate, the difference where the rail is cheaper, you'll be saving not a lot of money if you're only shipping 1 ton 100 miles, right? So for shorter distance shipping, rail savings may not be as significant, and you may just want to get there faster, but for longer journeys, the savings can be significant. Okay, so we already talked about these advantages. I'm not going to repeat myself. One advantage that they have that we didn't talk about on the last slide is high flexibility in product type. So there are many different types of rail cars. You have reefer cars or flatbed cars with reefer containers on top that can ship refrigerated goods. You have fuel tank cars which can carry fuel, gasoline, chemicals. You have hopper cars which can carry corn or agriculture produce. They're called hopper because they're loaded from the top. The top opens, you load the car from the top. So they can move all sorts of stuff. They can move hazardous materials. There's certain rail cars designed for that, right? They can carry containers, sometimes two containers on top of each other, like I showed in this picture. You can see stacked up containers being carried by the train. So they are very flexible in the different types of things they can carry. That's a big advantage. Reliability and safety are important and are generally good. Accessibility can be a problem because you have to take your product, your cargo to the train terminal, and for that you just use truck with it. But then there's a payment involved. You have to pay the truck to take it to the train terminal and so on. So the efficiency of the rail does come at a cost. There is a trade-off here. Okay, there's almost always trade-offs in logistics. So there's a trade-offs. Transit times are long and less reliable than TL shipments. So not only are they long, they're also less reliable, and that can increase your safety stocks because your lead times are now going to be longer and the variability in lead time will be more. Okay. So we covered inventory and transportation cost calculations earlier. And if you recall, not in this lecture, in a different lecture, if you recall, the safety stock formulas, they use lead time and the standard deviation of lead time. So both your lead times will go up and the standard deviation in lead times will go up if you switch from truck to rail. But your transportation costs will go down. So you save on the transportation expense, but spend more on the inventory expense. Which change wins out? Do you save a lot more than what you spend extra and net you save, or net you spend more? You can do that calculation as we have covered previously in calculating inventory costs lecture. Okay. So dwell time. Hours or days spent in switching yards where cars are detached from one train sorted into another train. 70% of the time is spent in loading, unloading, moving within terminals, classifying and assembling cars or trains or waiting. So if your rail takes 10 days to take your cargo from here to Los Angeles, okay, it's probably traveling for maybe 5 of those days, but maybe about 10 of those days, or maybe 6 of those days, and maybe like 8, 9 of those days is just spent in different terminals, offloading cargo, loading, offloading cars, connecting cars, and all of that stuff. Long trains are more efficient but move slowly, averaging 20 to 25 miles per hour. Trains run on fixed schedules. So if your cargo isn't ready when the train leaves, you might have to wait a day for the next train. Rail networks are highly sensitive to adverse event and signal derailment. Crew shortage, mechanical failure in a hub like Chicago can cause a ripple effect of delays across the national network. And all of this, what they call like making a train, like breaking it apart to make a train going in a different direction, things like that. All of this stuff takes time and, is subject to delays, which can increase or decrease the time it takes. So there's more variability in the transit time. So sometimes, it gets done in 8 days, sometimes it takes 12 days, sometimes it takes 6 days. The industry, as I mentioned before, is pretty concentrated. 7 Class 1 rail carriers account for 90% of industry revenue, so they do most of the business. Class 1 carriers are those with $250 million or more in revenue, so there's the bigger players, as classified by Surface Transportation Board. And 4 of the largest rail carriers, which you should probably know their names, are CSX, Norfolk, Union Pacific, Burlington Northern. And now let's talk about air. The fastest, very reliable, but very expensive mode of transportation. So very fast line haul service, like going from airport to airport, capable of traveling at 500 to 600 miles per hour. Accessibility can be an issue because you have to get your cargo to the airport, but then you use trucks for that. Okay. Some air carriers haul nothing but freight, and some mix passengers and freight together. So in a passenger airline, you might have a cargo hold at the bottom, which will be filled by cargo. Transit times are the fastest, but rates are the highest by a long margin. It's really expensive, almost 30 times higher than rail in recent times, and 5 times higher than truck. And, depending If you look historically, it can be 6 times higher than truck. It's like multiple times more expensive than truck. I've given you the cost data in the beginning of the lecture as a plot. You can kind of look at that to see, how much more was air compared to truck in that data. Limited number of large carriers earn about 90% of the revenue, just like rail. Why? Huge capex required. You need to buy airplanes, which are really expensive, get all sorts of licenses and approvals, regulated industry. So it's not easy for somebody to just go out and start an airline. Like it is to go and lease a truck. If you have a truck driver's license, you can go to lease a truck and you become a trucking carrier company. But it's not that easy to become an air carrier company. You only use air for goods with a high value to weight ratio. Reliability is high. It is subject to weather, but it's pretty high reliability. Unless there's very severe weather, planes fly most of the time because they can go above the clouds and go above the regular type of, wind and rain type of stuff. You'll see electronics, auto parts, machinery parts, expensive equipment, expensive machinery, diamonds, jewelry, fashion, seasonal flowers, because they have short shelf life, and some fruits and vegetables, which are like seasonal and kind of expensive, which also have short shelf life. Those sorts of things will be moved by air. Now, air does their costing a little bit differently. So we're going to go into detail in another lesson on the costing of TL, truckload and LTL shipments. Okay, because no matter which company you work for, you're going to probably end up using trucks. So that's really important. And you might use air sometimes. So the air shipping is the air transportation rates work a little bit differently than trucks. So they use something called volumetric weight. So we're going to talk about that. Okay, now imagine if air cargo charged you to ship by weight. Okay, this is the price per ton to ship something from city A to city B. You could go to the airport with a truck full of ping pong balls and be able to ship like multiple airplanefuls of ping pong balls for a very low price because the weight is so low. And you say, oh, in 1 ton, I can have so many ping pong balls in 1 ton. I'm just going to send planes full of ping pong balls because per ping pong ball, the cost is reasonable because they gave me a cost per ton. And because the air cargo space is very limited, very expensive, because the air fuel jet is expensive, airplane pilots are high wage employees, they're expensive. So the cargo hold in an airplane is very expensive space. You don't want to fill it up with low value goods like ping pong balls. And if they did give you a price per weight and you started bringing very light stuff to ship, you would just use up all that space and the airline will get very little revenue from you. So they don't want to do that. So they want to charge you for volume as well if your goods have low density, if they're very fluffy, not bulky goods. So what they do is they calculate the actual weight of your cargo and then they calculate the volumetric weight. So volumetric weight, there are 2 formulas, whether you want to calculate in kg or pounds. In the US, oftentimes it's done by pounds. In the rest of the world, it's often done in kgs. I'm giving you both formulas. So for kilograms, you take the length, width, and height, like you're shipping like a cube or a container or like a small container or a metal box with your stuff inside. So you measure the dimensions of that in centimeters. Remember that centimeters. You multiply the 3 numbers to get the volume, divide by 6,000. That's going to be your volumetric weight in kilograms. Okay. And for pounds, you take the dimensions of your box in inches. Multiply the 3 dimensions together in inches, divide by 166, you get the volumetric weight in pounds. You might have seen, if you have shipped a lot of packages with like UPS, you might have noticed that they measure your package and also weigh it before giving you how much it's going to cost you. They're doing the same thing. Parcel shipment by UPS or FedEx does something very similar. So that's why they have some pre-sized boxes that you can fill up where they already know the volume of the pre-sized box. But if you just take your own packaged box, they're going to measure it and put it in the system to do this calculation. And then the billable weight, what you're billed up on, is going to be the maximum of actual weight and volumetric weight. Whichever is higher, they'll take that. If the actual weight is higher, that means you're shipping something really dense and heavy. Then they're going to use the actual weight and charge you a lot because you're shipping more weight. But if you're shipping something very fluffy like ping pong balls, they're going to use the volumetric weight. That's going to be much higher than the billable than the actual weight, and they're going to bill you for the volumetric weight because you're using up a lot of space in the airplane. Okay, let's look at an example. Let's say you're shipping some heavy cargo. The actual weight is 150 pounds, but the dimensions are small, 20 inch by 30 inch by 6 inch box. Okay, so if you do this 20 inch by 30 inch by 60 inch and you divide by 166 to get the volumetric weight in pounds, you get 21.7 pounds. So what are you going to be billed upon? The larger of the two. The larger of the two of actual weight and volumetric weight is 150. You're going to be billed for 150 pounds, even though your device takes up a small amount of space. And think about more bulky cargo, which takes a lot of space. The actual weight is only 30 pounds, but the dimensions are 48 inches by 32 inches by 6 inches. The volumetric weight is 55.5 pounds. So what is you're going to be billed upon, not on the actual weight, because your thing is too fluffy, takes up too much space. So you're going to be billed on the volumetric weight of 55.5 pounds. So the billed weight is always the higher of the actual weight and the volumetric weight. Okay, so those are the main things you need to know about air. Now let's talk about water. So first we talk about domestic water carriers, which are available along the Atlantic, like along the coast, the Gulf, the Pacific coast, and along some rivers, Mississippi River, Missouri, Tennessee, Ohio River systems, and the Great Lakes, which go around Michigan, Illinois, Wisconsin. And these water areas or waterways, we use a type of a ship called a barge. Okay. The regulated common and contract carriers, they haul about 5% of the freight, while private and exempt carriers haul 95% of the ton miles. So you have, two types of carriers that are available. Typically a long distance mover of low value bulk type product like agriculture products, lumber, gravel, sand, things like that. Extremely slow because, the barges, they move at 5 to 9 miles per hour, whereas rail can go average up to 30 miles per hour or 25 miles per hour. Trucks will average 50 miles per hour. So like really slow. Low rates, long transit, very low rates, very cheap, even cheaper than rail. But close, not like drastically cheaper than rail, but close, and very long transit time. Low accessibility because you have to be along these water bodies of water like lakes or seas or river systems for the barge to kind of go on that and for you to be able to use this. Now the second type, now that was one type, domestic water carriers. Now on the international oceans, you have these huge ships which carry containers. They account for 81% of international trade. Air accounts for most of the rest. Because when you're going from Europe to America, you have to cross large bodies of water. Trucks can't do that. It's either the ocean carriers with container ships on oceans, or air. Those are the two options you have. So you can see that there's a lot of international trade that uses air. And why? Because it's a high value dense good. They're like iPhones or semiconductor chips, electronics, those things can be shipped internationally by air, especially because you have a lot of money tied into those things. It makes sense to send a shipment of iPhones on air because you want to be selling them. You don't want your money tied up in iPhones that are just sitting on a boat somewhere and taking like a month to get to the destination. Okay, so international ocean carriers, also called container ships because they carry a lot of containers on them. You can have container ships or general cargo ships. Most of the trade now takes place on container ships. Cargo ships are just like a big ship with a huge cargo holds, and then you can load your boxes or pallets into the cargo holds. Okay, they have some cranes or system on them to move your stuff into the cargo, but they are not as popular because it takes a long time to load and offload them. Whereas in container ships, you have this big train, it just picks up a big container, 20-foot or 40-foot equivalent, just moves the whole container, stacks them up on top of the ship, and off you go. So container ships have high speeds for ships, increasingly more common, more important. Most of the international trade now happens on container ships. Larger vessels, so I fixed the typo. Larger vessels these days can handle 9,000 to 12,000 40-foot containers. That is a lot. Okay, and I'll give you some sizes of these big large ships now, and they're going even beyond that. So really huge ships, carry a lot of stuff. Very popular option for international trade, generally reliable when they're on the water, when they're moving from one port to another port. But the ports are where the delays can happen. Port congestion can be a problem. Cranes falling over, accidents, strikes at the port, things like that. Customs clearance at the port. Those things can be unreliable. But once it left the port and it's on the water, it's pretty reliable. The transit time point port to port is reliable, but at the ports it can take time which is variable. There's also tankers for oil and gas, and they're also huge ones. And so unless you're doing oil shipping or gasoline or something like that, you'll mostly be dealing with container ships and rarely general cargo ships, but mostly container ships. Okay, so let's look at some of these pictures. These are two Ever Ace. It's actually a real ship called Ever Ace. By Evergreen, and then MSC has the Loretto. These are huge ships. They're called Megamax 24 class. Okay, why are they called Megamax 24? Because they can carry 12,040 feet equivalent containers, the bigger container, which is equal to 24,000 20-foot equivalent containers. 40 feet is a dimension, the length of a container, or you can get 20 feet containers as well. So they can carry 24,000 TUs, 20-foot equivalents, which is where the 24 comes from. Megamax 24,000 TUs. They cost about $165 million. And then these are pictures of the actual ships. They can carry a lot of stuff. Okay, built by a handful of specialized yards in South Korea and China for global shipping giant companies, and these are called ultra large container vessels, or the Megamax 24 class. Okay. A lot of the ships are not going to be this large. A lot of the ships are going to be 9,000 FEUs, 8,000 FEUs, 9,000 FEUs. These are the largest ones. And they're trying to go a little bit larger as well. Now, the total size is still going to be limited because they have to pass through like the Panama Canal and things like that. So those canals have a certain depth. And then, a ship can only be so much large to pass through them. Okay. But to make these efficient, there's a lot of technology in them. To make them fuel efficient, and that is why international trade has taken off so much, because international shipping has become very cost effective. To build a ship across the world is not that expensive, and it's become pretty reliable. It is slow, but it's reliable and it's cheap, so people can handle that. Now these ships, these 12,000 FEU ships, the Megamax 24 class, their length is about 400 meters. And the deck area is about 4 football fields, about 24,000 square meters, about 4 football fields equivalent of deck area on which they stack those containers. They're most efficient in what they call slow steaming mode, 16 to 19 knots, but they can push, speeds of above 22 knots. And, they've become much more efficient over time. The last couple of decades, these large ships have become extremely fuel efficient. Okay. Now, if you go for the biggest ship, they're not going to be available on all the routes because only a few of the larger ports have the big, huge cranes to load up this ship fully. Because if the crane is not that big, it can't reach all parts of this huge ship. And so a lot of times you'll be using like 9,000 FEU ships, which are very large too, right? About, 75% of this ship. So 8,000 FEU, 6,000 FEU, 9,000 FEU. A lot of times you'll be using ships of that size, but these are like the big ones. So speed of ocean carriers ranges from 10 to 26 knots, which is 11.5 to 30 miles per hour. So 30 miles per hour is like train speed. So their top speed is like on the little bit faster end of trains. The big cargo trains. I'm not talking about passenger trains. They're high speed passenger trains that go much faster. So don't tell me, but I took this high speed train in China and I went at 200 miles per hour or something like that, or I took a bullet train in Europe, something like that. I'm talking about cargo trains with lots of rail cars. These long cargo trains which are really fuel efficient but move slowly. These ships are, slower than them usually on their slow steaming fuel efficient mode, but if they go to their max speed, they can match the train speed. Okay. For example, the Maersk Triple E averages 18.4 miles per hour or 60 knots in slow steaming fuel efficient mode. Transit reliability, again, is a mixed bag in a sense that reliability between ports is high. When you leave the LA port and you're going to the Shanghai port, that time is very predictable, how long it's going to take to go on the ocean from LA to Shanghai. But how much time it spends in the LA port and how much time it spends in the Shanghai port, that time is getting more reliable. It's getting, the port operations are improving every year, but sometimes it can be unreliable. So the total reliability of the total transit time really depends on which ports are being used. Some ports are more reliable than others. Okay, self-test question. For transportation between 2 points at least 800 miles apart, which is the fastest? Truckload LTL, truckload TL, rail, water barge. We know rail and water barge are like slow. Rail is going to average 20-25 miles per hour. Water barge 5 to 9 miles per hour. Trucks average 50 miles per hour. So it's going to be A or B. So which one is going to be faster? It's going to be TL, because LTL has to do a milk run to collect the product. It's not just shipping your product, it's shipping somebody else's cargo as well. So it's going to do all the collections, go to the terminal, sort it in the terminal. Line haul trucks are going to be made, loaded, do the line haul, go to another terminal at the other side, and then do a milk run to do the deliveries. So that is a lot of operations in LTL, and moving goods around in the terminals takes way longer than TL. So TL, truckload shipments by truck, are going to be the fastest. Last mode of transportation before we are done, pipeline. Okay, used for oil, gas, liquid fuels, etc. There's been some research has been performed to move minerals in a liquid medium. So let's say you mine some iron ore and you want to move the iron ore, mix it in a liquid and move the slush down a pipeline. But it's not, outside of a few attempts to transport slurried coal, no real successes have occurred. So mostly just used for oil and gas. So not used outside of these special purpose. If you're not in the oil and gas industry, you can basically ignore pipeline unless you come up with a nice way to ship packages in, I don't know, maybe you push air through the pipeline and push your packages through them. Maybe you can do some cool research and come up with some way to move packages or pallets through a pipeline. That'll be super cool. You could think of ways, right? You could put some skater wheels on a pallet and just kind of have it skate through a pipeline if the pipeline especially is at an angle. You can try to think of those things, but mostly right now being used for oil and gas. Accessibility is low because you must lay down the pipeline to the destination from the source. So usually it's laid down from a point of extraction when you extract oil and gas. There's your big oil field or something. Maybe you start the pipeline there. And these can go under the ocean as well, undersea pipelines, and then you go to some big destination cities with terminals where you take out the fuel, or to a refinery, then from a refinery on to big cities where you load up fuel tanker trucks and then you supply the gas stations in the cities. Cost structure is highly fixed with low variable costs. So once you set up the pipeline, the cost of using the pipeline is really low, but it has a big capex required to set it up. Own rights of way, so there's no issue of congestion. Like if your company owns the pipeline, you can pump your oil and gas through it to your heart's desire. Major advantages is a very low cost of transportation. If you were to ship all that fuel on trucks, or rail, that'll be so expensive. Pipeline is way cheaper for fuel and gas than trucks or rail. Okay, and works 24/7, works all the time, ships a large amount at a very low variable cost, but needs capex to set up. Okay. So we're not going to spend any more time on a pipeline because outside of oil and gas, not really used much. So that is it. So this lecture gave you a lot of facts. Hopefully, a cup of tea or coffee helped you along the way. But these were the basics you had to know before we get into transportation management. So hopefully now you have an idea of different types of transportation, their advantages, disadvantages when they're used, especially, the 3 or 4 key ones, which is truck, LTL and TL, rail, air, and then ocean freight transportation, like on those big container ships. These things you're most likely going to end up using in real life, so you need to understand these. Okay. So that's it for this topic for now.